Hello, everyone. Uh, this is Valentin Malykh, and I'd like to present you our work, Summary Construction Strategies for Headline Generation in the Russian Language. This is joint work of Kazan Federal University and Moscow Institute of Physics and Technology. Authors of this work is me, Valentin Malykh. I'm representing Kazan Federal University and two guys from Moscow Institute of Physics and Technology, Daniel Chernavsky and Alex Valikov. Also, I would like to acknowledge that this work was funded by Russian fund RFBR project number 1937-60027. First of all, I'd like to actually discuss with you what is the summarization. Summarization task is the task of getting shorter text from the longer one. The first one is called document, and the second one called summary. Actually, there are two basic approaches to this task. One is called extractive summarization, and another is called abstractive summarization. The extractive summarization is when you get a document, you split it into some phrases, say sentences, and you take some sentences into the summary. The abstractive summarization is another approach when you generate a new text basing on a document. So your summary is not directly extracted from the text. Okay, so the extractive summarization, when we are taking only some sentences from a text, it could be actually both supervised and unsupervised. And the supervised approach is based on some markup when we know which phrases are actually taken by a human. But in our work, we're using only unsupervised approach where there is no such markup. So there is only some internal measures which is helping us to understand which phrases should be taken. Okay, so the common approaches to extractive summarization is TextRank, LexRank, or some other ranks. The basic idea of this TextRank algorithm is this. So there is a text, we split it into the sentences, we vectorize them. The vectorization could be different. It could be, for example, classical TF-IDF approach, or it could be averaged word-to-vec, maybe some language models like BERT or some other languages. This is not exactly important in this case. After that, we're actually creating a similarity matrix between the vectors of these sentences. So we have similarity matrix for the sentences. And we construct graph where each edge is connecting one sentence to another if their similarity is larger than some threshold. And after this, since we have a graph, we could actually have some ordering or ranking. So we could use, for example, topological ordering or for example, PageRank algorithm application, like in TextRank. And after that, we actually have sentence ranking. And we choose only, for example, 20% of the top ranked sentences into our summary. And as we could see, the output is pretty good one. This is a really popular algorithm. Okay, but actually we are going to have the abstractive models here, and we using in our work some abstractive models. This is here on the slide is presented recurrent neural network, which is actually doing this. So we have some text. We read it with recurrent neural network, which is stores some information inside it. And after that, we have some context vector, which is used to generate some next words. So we have so-called encoder, which is producing a context vector, and we have so-called decoder, which is using context vector and previously generated vectors, previously generated tokens to generate new tokens. Okay. Another baseline is transformer. The transformer model is a huge impact, has a huge impact on the NLP field in the recent years. And it is also has this encoder-decoder structure as a recurrent model, but it has its own specific features. For example, the encoder here is so-called transformer. So this is only specific attention mechanism, some additional normalization, feed-forward normalization, and that's it. So we have no exact recurrency here. We have only bag of words, more or less, and all of the words or tokens are actually somehow dependent on each other words. So to have some recurrency, to understand what is the ordering of the words or the tokens, we use so-called positional encoding for the input, and merge the positional encoding with input embeddings, and feed it into the transformer module. And there are actually n transformer models. In the original work it was 6, and we also use 6 in our work. And to produce outputs, we also use all the same. This is at first output embedding, the positional encoding for the positional information, but we also use masking to actually mask the future from the decoder. And we use mask multi-head attention, some normalization, and next we use the context from the encoder and the output of the previous masked attention. And after that we use normalization, feed-forward normalization, and after that we use softmax to produce some output. Okay, so this is the transformer baseline. Next, I'd like to discuss with you the metrics which are actually using in the summarization field. First of all, we need to get this Rouge metric. Rouge is a metric which is comparing some n-grams. Actually, there are 3 typical Rouge types when we use unigrams, bigrams, and when we use the longest possible grams, longest possible substring. So the idea here is what we use is actually that we have match of the words, counting of the words, and we are trying to understand how many words from the references there are in the hypothesis. So there are actually some types of what could be done. We could use only the words which are actually there in the hypothesis. So this will be the recall. So when we are dividing the words which have been in the hypothesis for the reference, there could be a precision when we divide all the words in the hypothesis to the all the words in the references, and we could use their mean, geometric mean, and this is what we call Rouge F1 measure. So there are actually 9 types of Rouge, but we in our work use only Rouge 1, Rouge 2, Rouge L in the recall and F measure matrices. So we actually could use the precision also, but this is excessive. Okay, another metric is so-called extraction score. The extraction score is a bit another thing. It is using only the non-overlapping common sequences, the most longest one, which the sequences are longer than some specific threshold, for example, 10 words or something. And this score is aimed to actually represent how extractive the summary is based on the original text. Okay, so we have discussed the summarization task, and we discussed the metrics which are used for this summarization. And now we have our hypothesis, which is pretty simple. The hypothesis is that we could improve the abstractive summarization results using the extractive summarization output. Okay, I think it's pretty much understandable. And what could we use? We call this hypothesis we need to elaborate, and we call this idea summary construction strategies. So we construct summaries which could be constructed somehow. For example, it could be whole body. So this is the simplest baseline. We could use the first sentence. So we use only the first sentence from the whole body. This should be said that we're actually skipping the first sentence for the sum of the news documents, because the first sentence commonly is containing the place and date, and this is not really important information for the summary. And we skip this information and use the next sentence. Okay, the next summary strategy is 3 first sentences, when we actually use 3 first sentences and also skipping this uninformative first sentence. The next strategy is unsupervised summary, when we using the extractive summarization and using it output as input for the abstractive model. And the last is so-called named entity recognition summary. This is a hypothesis where we saying that the important information in a news document is only in the sentences which are actually containing some named entities. So this is the 5 summary construction strategies which we are going to discuss later. So at first, let us look at the summaries themselves. So this is the summaries, and here we skip the whole body because this is have no sense, because it will have the 1 scores everywhere. And as we could see, the third sentence summary is pretty good as abstractive summary. It has the best Rouge 1 recall results and Rouge L recall results. On the other side, the named entity recognition summary is the best of the extractive score. So it contains the least directly extracted information from the text. So let us discuss the RNN results. The results for the RNN baselines is like this. So as we could see, if we use sequence to sequence or RNN with 1 cent, 3 cent, full body, unsupervised summary, empty recognition, we could see that Rouge 2 recall is second best for this 3 sentence plus RNN baseline, and the second best extractive score is also for named entity recognition. And as we could see that the extractive score for the sequence to sequence or RNN models is higher than the summaries, constructed summaries themselves. So this is actually really interesting finding, but this is not all. The most interesting part is the results for the transformer models. So we have transformer models which are using the same results, the same strategies for summary constructing. And as we could see, there are the best results for Rouge 2 F measure and Rouge 2 recall are the best for the whole baselines and the other approaches presented previously. So also this baseline is second best in every other metric except the extraction score. And interestingly, all of the most of the transformer models are actually have higher extractive scores comparing to the sequence to sequence and to the extractive score from the and the extractive score from the summaries themselves. And as we could see, we have here best results, not for all, some best results for the previous work, but still our work is at least second best everywhere. And at last, there is a result of the output of our models, like the original text, which is discussing some fire in restaurant El Gaucho in Moscow. And as we could see, the original headline is actually have more details, but we could see that the headlines themselves are actually not really that bad. The headline from Transformer plus 3 cents, it is almost the same. It has the same meaning, but it is reformulated. So it is not the best score, but the meaning is the same. The other baselines showing that they have had the main information about that the fire is already liquidated, but the information about some casualties is gone. So this is actually it. Thank you for your attention. This is again my context, and I would like to answer your questions. Thank you.